let us start in on Unit 2. Unit 2, we are going to discuss the chemistry of the human body. We do have some useful videos. And here's a sampling of what we're going to cover. Let's begin. What is chemistry? Chemistry is going to be what makes up everything. So a couple of terms you do need to be familiar with. Matter. Matter is the stuff of the universe. Elements. Elements are the simplest form of matter, and every single one of them are going to have unique chemical properties. Those unique chemical properties are going to be based upon their number of electrons, protons, and neutrons. We'll talk about those in a second. The electrons, protons, and neutrons are going to be what are going to make up the atoms. Atoms are the base molecule, what interacts in chemistry and in various other reactions. Every atom, or actually I should say every element, is going to have a atomic number attached to it. The atomic number is based upon the number of protons which are found in the nucleus. Protons have a positive charge to them. That will come into play later. The periodic table is where you're going to find all of the elements that we are aware of. Some of them are natural, some of them are man-made, and the periodic table is going to have those arranged by their atomic number. Every element is going to have 1, 2, 3, usually, letters that are unique to that element. Now, these letters are usually based off of their name, and that's usually going to be in the Latin format. All right, so every atom, as I mentioned, has protons, neutrons, and electrons, and they're arranged in such a manner that the neutrons and protons will be found in the center of the atom and make up its nucleus. Every proton and every neutron is going to have a mass of 1. So the atomic mass, which is also associated with every single atom, is going to be the total of the protons and the neutrons. You might be asking, but there's electrons too. Why aren't they in the mass? It's because they weigh so little. They weigh so little, and some atoms have so few that we just don't take them into account. Protons have a positive charge, as I mentioned. Neutrons have a negative charge, or a neutral charge. All right. Now the electrons, those are not found in the nucleus. Those are going to be found spinning and circling around the electron in shells. The number of shells or rings that the atom is going to have is going to be dependent upon the number of electrons it has. In a neutral atom, the electrons are going to equal protons. So if I have 11 protons, I will have 11 electrons. And they're arranged in such a manner that the first ring will have 2, and then every ring around that will have up to 8. So in my example of 11 electrons, we'd have a ring with 2, and then we'd have a ring with 8, and then we'd have a ring with 1 to bring us to a total of 11 electrons. This comes into play later on when these atoms are interacting together, because these atoms want to have 8 in their outer ring. It's the octet rule. That is their stable state. So some of these atoms are going to give up an electron or 2 or 3, depending on how many are in their outer shell, to bring them to 8, and some will gain 1, 2, or 3 in order to fill out their outer shell. And this is going to determine how they interact with other atoms. This is going to determine some of their chemical behavior, and we'll talk about some of that. Here's our periodic table of elements. Do you need to memorize this? No. Should you be aware of the most common element symbols. Yes, so things like carbon right here, nitrogen here, oxygen here, chlorine, sulfur, phosphorus, iodine, copper, iron, hydrogen. Some of the more common ones. This is an example of an atom. Here we have our neutrons and protons, and here we have our electron shells, starting with the 2 in the innermost and then going out from there. Here you can see examples of those shells based on the number of atoms, or not atoms, of electrons. All right, now in the world of chemistry, you will come across something that is known as an isotope. These isotopes are elements that have an abnormal number of neutrons. So where normally a hydrogen would have 1, not even 1 neutron actually. That's a bad example. Yeah, no, we're going to stick with hydrogen. Hydrogen has 1 proton, no neutrons normally. If it has 1 neutron, it'd be an isotope of H1. H2 would indicate that it has 2 abnormal neutrons. The adding of neutrons is going to make the atom heavier, so increase its atomic weight because every neutron is 1. And this will bring to something known as heavy water. We're really not going to touch on that here. That being said, even though it increases the atomic weight, it will not change the chemical behavior. So it's still going to have the number of electrons. The electrons are still going to interact with other atoms the exact same way. So that atomic weight, as I mentioned, is based on the average of a sample. So we took 150 atoms and did a scientific weighing, which we're not going to get into that process here. That's something that we can talk about in an actual chemistry class. But they took them, they weighed them, and that was the average. It was an average of 1. So in that sample size, you would have had isotopes with 1, 2, or 3 neutrons. Here's an example. All right, so what's an ion then? An ion is a atom, isotope or otherwise, that has an unequal number of protons and electrons. So if it is a atom with a positive charge, it gave up an electron. If it is an atom with a negative charge, it took on an electron. And here is an example of this. This is actually a classic one. Here we have a sodium atom and a chloride atom. The sodium wants to get rid of this lone electron in its outer valence shell, and the chlorine wants to pick up one to finish filling in its outer valence shell. So here we have that exchange. Having 8 increases that stability. Now some terms that we need to know for ions. If it's an anion, that means it gained an electron, it has a negative charge. If it's a cation, it lost an electron and it is a positive charge.